Alright, so I'd like you to just observe these three sides that I have here, and I'm going to select all three of them at the same time. I'll just do it that way. I'm going to copy, and I'm going to paste, and I can drag them away, and these, here we go. So the ratio between the original sides and the new sides would be a ratio of 1 to 1. They're exactly the same size. Now let's take one of each and move them out of here, which sometimes can be more difficult than you'd think. Okay, get one blue out of here, one of these yellows, and one of these reds. Again, these are proportional to these. There's a 1 to 1 ratio between the reds, a 1 to 1 ratio between the blues, and a 1 to 1 ratio between the oranges. Now I could take all of these guys, select them all, and if anytime I pull this lower right hand corner, they will grow in a proportional rate. Okay, so I think about there looks about double, would you say? Let's compare this red one. I mean, it's close, right? But these are about double these lengths. So now there would be a ratio of what to what? We could say 1 to 2. For every 1 unit of length here, there are 2 units of length over here. Okay, so let's go ahead and say that these sides over here are proportional to these sides. And I just kind of showed you that. Okay, so what happens when you make a triangle out of 3 sides? And then you again make a triangle out of 3 sides that are proportional to the first 3. What's your visual observation here about these two triangles? Are they congruent? Are they completely different, different classifications, or what? You probably are thinking they look pretty similar. So if I take this one over here and I drag it over here, now one way we can decide that these are in fact similar is we can use the angle similarity postulate, which we already have come up with. Okay, so we can observe that this lower left hand corner right here, that these angles fit snugly together and they are congruent, and over here in this lower right hand corner, these two angles fit snugly together and are congruent. So by the angle similarity postulate, angle similarity postulate, we can conclude that these two are similar. We don't even really have to measure the sides. Alright, so let's look at another example. This time I've got 2 sides here. I'm going to duplicate them. Right now the 2 oranges are congruent to each other, the 2 blues are congruent to each other, so the original orange and blue have a ratio of 1 to 1 with the new blue and orange one. But let's change that up. So let's take a blue and an orange and let's shrink them down to size. Okay, let's make it a little more interesting this time. And why don't you go ahead and predict about what do you think the ratio is of the big to small sides, big to the small sides that match colors. What do you think? About how many times bigger do you think this is compared to this? You're probably thinking maybe 3 or 4, somewhere between there. Let's see. So I'm gonna copy and paste. I put it up there. You can see there's 2 units, 3, 3, and how much more do you think that is? Oh, pretty much a half, 3.5, right? So we could say that the ratio is for every one of the small ones, let's say small to large, for every one of these small ones, there's about 3.5 of these. 1 to 3.5. And actually, let's just write that down real quick. If we did, again, we're doing a ratio of small to large. Just give me a quick second. We're going to do small to large for these ratios. And so the small one, we said, let's call that 1, right? And we said they're about 3.5, right? So for every one of these, you've got it takes 3.5 of those to make one of these. So I think we should get this without decimals. So that would be 2 to 7, right? Because if you double 1, you get 2. Double 3.5, and you get 7. That's just a little side note, but we can forget about that. Okay. Let's get back to what we were doing here. Okay, I'm going to make a triangle out of the big pieces. Alright. I'm going to change it up a little bit. Let's see that. Let me change this one up a little bit. Okay. Let's change it up a little bit. Okay. So we are going to pick the third side for these triangles. Make it red. And you could imagine what this third side would be, but we're going to fill it in. Oops. Stay there. Hey. I meant to do this one. Okay. Alright. And that's good enough. Alright. So, now, do you think that these are similar triangles? Keep in mind, you know, we did make the blue and the orange sides proportional. But hold on, wait a minute. If these were similar, I should be able to see that the corresponding angles are congruent, and there's no way that those are congruent. We can try to fit that angle in there. It ain't fitting in there. Let's see this angle. These aren't congruent. I mean, those are almost, no, those aren't even congruent. That doesn't really fit in there very well. Okay. So why is that? What's the difference between the first example we did and this example? Well, in this example, there's something that we could do to make these the same. Something a little different. Let's get rid of the red sides that we added. Okay. And I bet some of you are probably thinking, if we had the same angle for both of these, right? So, do you know what I mean? If we have the same angle here as we have here, then maybe they would come out to be similar. Let's move them closer just to make sure we do have the same angle. Rotate that a little bit until the blues are parallel, make the oranges parallel, and then just translate them to be together. And then once you have them together, that's kind of difficult to do. We can then see these are congruent angles. So now let's add the missing side. Where are we? We're going to add that third red side. Oop. Let's group this. And now, look at that. Look at that. I think it's very clear that these are similar. And as I make it larger, that one's a little off there, but you get the idea. That guy right there. Alright. And so that's how we come up with these postulates here. Or theorems, I should say. We got one postulate, two theorems. Here's your three sides. If three sides of one triangle are proportional to three corresponding sides of another triangle, then the triangles are similar. Let me adjust that for you. Here we go. Side, angle, side. Similarity. If two sides of one triangle are proportional to two sides of another triangle and their included angles are congruent, then the triangles are similar. And that is that.